Hey, what we're going to do now is a quick overview for working with rational expressions. So you won't get a whole lot of detail about how to do these problems, more of either just an overview of how to do them or a review if you've already gone over them. So we're going to start with simplifying. When we simplify rational expressions, we're going to start by factoring the numerator and denominator. Then we're going to list the excluded or restricted values, which we get by setting the denominator not equal to 0. And then we're going to cancel legally. So let's start with this example here. We have x squared plus 10x plus 25, which we will factor into x plus 5 times x plus 5 by the AC method. And then x squared plus 9x plus 20 factors to x plus 5 times x plus 4. So we have now factored the numerator and denominator. Then we're going to list the excluded values or restricted values, and we do that by setting the denominator not equal to 0. So we'll take x plus 5 times x plus 4 cannot equal 0. And then we set each of the parts that contain a variable not equal to 0. So x plus 5 can't equal 0. X plus 4 can't equal 0. And then we solve each of these. So we get x cannot equal negative 5. X cannot equal negative 4. So those will be our excluded values. Then the next thing we'll do is cancel legally. That means that you have to have an exact match in the numerator and denominator. So I have an x plus 5 and an x plus 5 that will cancel. And then I'll end up rewriting my problem with what's left, which is x plus 5 over x plus 4, and that is my simplified answer. On to division. When we divide, our first step is to factor the numerators and denominators again. So we'll start, gosh, we've got 4 to do here. So in the first top left numerator, we have GCF of 2x. Divide 2x out of 4x squared, we get 2x. 2x divided by 2x is 1, so 2x times 2x minus 1. And then AC method, so x plus 4, x plus 1, divide by. 2x isn't going to factor because there's nothing squared, no GCFs there. So we leave it 2x. And in the denominator, x plus 1 times x plus 1. So we have factored the numerator and denominator. The next thing we're going to do is list the excluded values like we did before. So I would take each of my denominators and set it equal to 0. So x plus 4 times x plus 1 equals 0, which if I solve it like it did over there is going to give me that x cannot equal negative 4 and x cannot equal negative 1. And then in my other denominator, set each of those equal to 0, not equal to 0. So x cannot equal negative 1, which is already listed, so I don't have anything new to add there. So I have listed that. Next we're going to keep it, change it, flip it. That means we keep the first fraction exactly the same, change division to multiplication, flip the second fraction. So now my problem is 2x times 2x minus 1 over x plus 4 times x plus 1 times 2x over, whoops, excuse me, I forgot to flip it, x plus 1 times x plus 1 over 2x. So keep it, change it, flip it. And then I have to list new excluded or restricted values. Because I switched the numerator and denominator here, now I have to pay attention to this denominator, and I need to set it not equal to 0. So 2x cannot equal 0, divide by 2, x cannot equal 0. So now I have to add x cannot equal 0 onto my list of excluded values. And then on to the next step of canceling legally. So I can only cancel things that match exactly. So if I look, I have an x plus 1 that can cancel with an x plus 1. I have a 2 that can cancel with a 2, and I have an x that can cancel with an x. nothing else is going to match, so I'll multiply straight across, but I do not FOIL or distribute. So I have 2x minus 1 times x plus 1, and then it's over x plus 4. And I can put that x plus 4 in a parenthesis or not. It's really a matter of personal preference. But then we would be done. Next, we are multiplying. Well, when we did division, we really already did multiplication because we changed our division to a multiplication. So this is kind of going to be a rerun of what we just did with division. So we start out the same way, guess what? By factoring the numerators and denominators. So see, x squared minus 2x minus 24 would be x minus 6 times x plus 4. And x squared plus 7x plus 12 would be x plus 3 times x plus 4 times, oh, difference of squares, x squared minus 1 would be x plus 1, x minus 1, and then over x minus 6. Now before we get too carried away, we are going to list the excluded or restricted values by setting each part of the denominator that has a variable not equal to 0. So a piece at a time, x plus 3 cannot equal 0 gives me that x cannot equal negative 3. X plus 4 not equal to 0 gives me x cannot equal negative 4. And x minus 6 not equal to 0 gives me x cannot equal 6. So there's my restricted values or my excluded values. Next, we will cancel legally. So anything that exactly matches, like x plus 4 and x plus 4. I also have an x minus 6 here and an x minus 6 here. Even though that's not in parentheses, it is multiplied, so I can cancel the x minus 6's. And then nothing else matches, so we go ahead and multiply straight across, but we're not going to FOIL or distribute. So we'll leave the x plus 1 times x minus 1 just like it is. And it's going to be over x plus 3, which again can have the parentheses or not, just up to you. So that would be our simplified answer. Adding and subtracting is probably the most complicated operations. So we're going to work on getting a common denominator. That's the toughest part, I would say. To get a common denominator, we're going to factor the denominators and then multiply each term by what's missing so that we end up with common denominators just like we do when we're adding and subtracting fractions. So we start by factoring. So I'll do this example. So 3x over, that's a difference of squares again. So x plus 2, x minus 2, plus 6 over x plus 2. Now it's probably a good idea to go ahead and put that x plus 2 inside parentheses so that we can see what we need to make the two denominators match. Well, the first denominator has x plus 2 times x minus 2. The second one only has x plus 2. So we need to multiply by x minus 2 to make them match, which means I also need to multiply the numerator by x minus 2. So we have factored and multiplied by what's missing. What we want to do is not FOIL the denominators, but we do want to FOIL and distribute the numerators. So I'm just going to rewrite this, and I'm going to go ahead and distribute that 6 across to make it 6x minus 12 over x plus 2 times x minus 2. Then we're going to list the excluded and restricted values. That shouldn't say new. Actually, I did these two steps in reverse order. It doesn't really matter. You can FOIL and distribute first or list your restricted values. We set each part that contains a variable not equal to 0. So I'd have x cannot equal. X plus 2 can't equal 0 gives me x equals negative 2. X minus 2 not equal to 0 gives me x cannot equal positive 2. So there's my excluded values. And then I'm going to add or subtract the numerators, being careful with the signs. So I'm going to do 3x plus 6x minus 12, which will be 9x minus 12, over, we just keep the denominator the same, x plus 2, x minus 2. Then we need to see if we can factor the numerators. So in the numerator, there's just one numerator, we have a GCF of 3. So that'll be 3 times 3x minus 4 over x plus 2 times x minus 2. So then we want to see if we can cancel anything. Remember, to cancel, everything has to match exactly. So I've got a 3x minus 4, an x plus 2, and an x minus 2, which means nothing's going to cancel. So this ends up being my final answer. We're going to do one more example. This one's going to be subtraction. So we've got 1 over x squared minus 1, subtract 2 over x squared plus 3. So we've got to go through the steps of getting a common denominator. So we're going to factor the denominators. So we've got 1 over, that's a difference of squares, so x plus 1, x minus 1, subtract 2 over, this one just has a GCF of x, so x times x plus 3. And then we need to multiply each term by what's missing so that we can get a common denominator. The first denominator has an x plus 1 times an x minus 1. The second denominator has an x times an x plus 3. So I've got to make them match exactly. So I need to multiply this denominator by x plus 1 times x minus 1, which means I also need to multiply the numerator by x plus 1, x minus 1. And then to make this one match that one, I need to multiply it by x plus 3 and x, which means I also need to multiply the numerator by x plus 3 and x. We can go ahead and list our restricted values now or after we FOIL and distribute the numerators. Last time I did the FOILing first, or distributing. So if I look at multiplying my numerators out, the denominator is still going to stay x, x plus 3, x plus 1, x minus 1. We're not going to mess with multiplying the denominators out, only the numerators. So I'm going to take x times x plus 3, which would be x squared plus 3x, and I'm multiplying that by 1, so it's not going to change my answer. So I'll just have x squared plus 3x. And then I have a subtraction problem. Now this denominator is that same big mess, x times x plus 3 times x plus 1 times x minus 1. And in the numerator, I'm going to multiply, from left to right. So I'm going to do 2 times x plus 1, which will give me 2x plus 2. And then I've got to FOIL that in with x minus 1. So when I FOIL 2x times x, 2x squared, outsides minus 2x, insides plus 2x, and last times last minus 2. So that actually works out really nicely for me because the minus 2x and plus 2x cancel. So this numerator is 2x squared minus 2. Now we'll go ahead and list those restricted values. So we said each part of the denominator that contains a variable not equal to 0. So I start here with x, and I set that not equal to 0. That gives me x cannot equal 0. X plus 3 cannot equal 0 gives me x cannot equal negative 3. X plus 1 cannot equal 0 gives me x cannot equal negative 1. And x minus 1 cannot equal 0 gives me x cannot equal 1. So this guy has 4 restricted values. And then we're going to go ahead and add or subtract our numerators, being careful with signs. This is the one you want to watch. When you have a subtraction in front of more than one term, this subtraction is actually going to go ahead and make this a negative 2x squared and make this a positive 2. So really the problem I'm doing in the numerator is x squared plus 3x minus 2x squared plus 2. So just be really careful with your signs. So when I combine the numerator, I have x squared minus 2x squared, which gives me negative x squared. And then 3x doesn't have any like terms, so plus 3x. And then minus negative 2, which makes plus 2. And then the denominator is going to stay x times x plus 3 times x plus 1 times x minus 1. Lastly, we need to see if we can factor the numerator. Now, when we start out with a negative leading coefficient, we always want to take out a GCF of negative 1. So I'll rewrite this as negative 1 times, divide out negative 1 leaves me x squared, 3x divided by negative 1, negative 3x, 2 divided by negative 1, negative 2. And then we have x, x plus 3, x plus 1, x minus 1. And then let's see if x squared minus 3x minus 2 will factor. We would use the AC method. And so we'd be looking for things that multiply to negative 2 but add to negative 3. And that's actually not going to work. So this trinomial does not factor. Since it won't factor and I don't have anything in common, then this is the answer to that subtraction problem. You'll get more details about simplifying, dividing, multiplying, adding, and subtracting from the 8.4 and 8.5 series of videos.